Welcome everyone to the Distinguished Speaker Series. We have today Phillippe Kruchten from the University of British Columbia up in Canada, in Vancouver. Phillippe holds an NSERC chair in design engineering in the Department of Electrical and Computer Engineering. NSERC is the equivalent of NSF in Canada, and to have an NSERC chair is pretty prestigious, up where I used to live as well. Phillippe has been with the department for the past 5, 6 years, but before that, he spent some 30 plus years in the industry. He's really a luminary in the software engineering community. He's made pretty important contributions, considered one of the pioneers. He's known as the father of the rational unified process, which has had a big impact on the community. He's extremely well known in the architecture, software architecture community, and his contributions are numerous. So what I'm going to do is I'm just going to turn it over to Phillippe and let him take it from here.
Okay, thank you very much. I can. Pretty bad to be the part is start. We're having a discussion in the background there. So we were starting with a demo here.
The only problem is that we're blaming the wiring, not software.
Okay, thank you. I think we're just on our own now. Um, so I was saying thank you for inviting me, and yep, I recognize the neighborhood. I used to work few miles from here. I used to do touch and goes on the landing strip over there, so once in a while for practice. So why is software so bad? And sometimes I'm wondering, is it really so bad? Actually, the actual title was a bit less polite. I had made a politically correct slide at the last minute with a typo, but that's how it started. Uh, so Hakan already went through the preliminaries, so I have, that's my retirement job. If you know the Peter principle, I've now reached my ultimate level of incompetence. I just teach undergrads. Um, I still continue to do some consulting with the frog company, as we call it in the family. Why frogs? Long story. French people eating frogs. Anyhow, Okan already pointed you at answer and a few other things. I'm one of the founder of Agile Vancouver, so that gives me a lot of insight on what's going on in the software scene around Vancouver. So that's the summary. What's this? That's a punch card, yep. So that's how I started. So I was an undergrad in mechanical engineering, and I realized that I could make a lot of money just by developing code in Fortran at the time. So I had about the whole wall full of cards when I left the campus. So after 2 years of writing Fortran for a consulting company, that's the car I bought, which in 1973 was pretty neat for a French guy. So lots of cards, lots of bugs on the cards. The bugs were relatively painful at the time because you had to type more cards. Reuse, where's Martin? Who is gone to Seattle? Okay, reuse was interesting because Ruben, they're back with us. So reuse was interesting. Part of the reuse was, Or do I have a continue card with a label of 60 or 70, that one less card to punch? Then a bit later, we had devices like this that were not very fancy, but let me just take the loudspeaker off. That's the very first computer that I really hacked a lot, both the hardware and the software. And some of you are old enough to recognize that's an Apple II. It's the European version of it. It didn't support French characters, so the first thing I did was just to add some wires and change the prompt so it would support E acute and A acute and that kind of thing. Anyhow, why am I telling you that? How is it connected to software so bad? When I got a degree in mechanical engineering, my mom's friends started to ask me questions like, "Oh, you are a mechanical engineer. There's something wrong with my car. Would you mind having a look at my engine?" And I would say, "Well, no, not really. I'm not that kind of mechanical engineer." But it continued. Anybody who had something mechanical that had a problem, they wanted me to have a look. And then this sort of faded away, and I forgot. But then around 1985, when people started to use more and more software, people said, "Oh, you're a software engineer. Well, I have a problem with Microsoft done something," and say, "Well, yeah, I'm not sure I really want to look at your operating system and your laptop and all that kind of thing." But people started to complain a lot, at least to me, that their software was so bad and it didn't do this and it crashed in this way, that way, and so on. So a few years ago, 3 years ago, after having random discussion with various people in various circles like IEEE, Computer Society, IFIP working, something like that, and various conferences, and having discussion where on various topics, but where the underlying theme is, are we getting better as a profession? I did a little survey, an informal survey, not a scientific one that would result in a journal publication. I just wrote to many friends about what was their view on the quality of software and the quality of our industry as a whole. So why is software so bad? You know, and I could have the tunes from whoever it was, the Beatles, with a little help from my friend. The first reply was a bit surprising. The question was, Philip, you're not quite clear. You know, is it bad for society or is it bad quality of the software? John Marasco in particular say, okay, is gravity bad? I can tell you, you know, it hurts when I fall down the stairs, and I'm an old guy, you know, I can blame it on gravity, but, you know, it's there. So maybe we have to be a little bit more qualifying when we speak about bad software. So what I really meant was, and I had to rephrase the question in my survey, why is the quality of software, especially the one that we're exposed to, because there's a lot of software we're not actually exposed to, so low? But also, at the same time, we have no really objective metrics. We can gather long list of incidents and irritants and irritations and mishaps and misuse of software, but it's very difficult to sort of assess the quality of software. So, and a lot of luminaries have looked into that and have made various pronouncements, some funny ones, some less funny ones. This one was repeated to me many times and actually resurfaced in my survey in some of the answers. Another one that's sort of annoying is the software crisis. So, yep, you know, the software crisis was mentioned very briefly in these famous NATO conferences that happened, you know, before some of you were born, before I actually wrote my first line of code, which was in 1917. It's about the same time. And the term software crisis started to spread in the world after a paper in Scientific American, at least in Europe. That's when I saw it. But with always the same thing. Oh, you know, software, it's so bad. If we had much more people developing software, we had more powerful tools. If software would be good. But it was mostly about a shortage of qualified people at the time, which seemed to imply that the quality and the delays and the things running over budget and things like that were due to the fact that we didn't educate enough good software people. Programmers, they were called at the time. Software engineers were still not invented as a term. Another thing that appeared around the mid-90s was the famous chaos report from the Standish Group, which clearly said, you know, most of what these software people produce is total crap. Uh, most of the projects don't even see the light of day, and the few that see the light of day, they're very late, they're very expensive, they're buggy, they run like when they want. And so that didn't help too much. This chaos report came at regular intervals, and the numbers seemed to improve a little bit. But it's not giving me the answer about the real quality of what we do, because the data that they use and the methodology that they use is pretty opaque. And a few people that I work with, like Chris Verhoef in Amsterdam, uh, and some Norwegian people have poked some holes in the methodology of the chaos report. So I'm not sure. Maybe they have a point, but there seems to be averaging all kind of things that shouldn't be averaged, things that have order of magnitudes in different size and quality and impact and things like that. So something that is a little bit more interesting is this very consistent collection of things more or less bad that happen with software that this gentleman has been collecting since 1985 and is still at it. Um, but there is very little analysis. There's just little reports about something. It's not really an indication of the quality of the software industry. They just collect incidents, bad things that happen because of software or in software, but it can give us some perspective. It would serve as a good starting point to do a proper assessment of the quality of software in some industries, at least. So there is always the really harmful stuff, the big disasters, the one that are repeated in classrooms and textbook again and again as, oh, look what happens when there are real serious bugs in software and people die. So the Terac 25, which has some Canadian roots, if I remember well, basically some medical instrumentation burning people. Um, the Ariane 5 launcher that blew up, the Denver airport luggage handling system, a few crashes of Airbuses, one just next to my hometown. Uh, so there's a few. But actually, if you dig a little bit, you cannot find that many. You cannot find hundreds and hundreds of really big disasters that can really be attributable to bad software, software bugs. Um, so the problem is, how do we speak about bad? What is quality? And that's also, curiously, a little bit unclear. So when in my survey I start speaking about quality, I also get some pushback. What do you mean by quality? You know, if um, if if you're looking at quality measured by the degree of acceptance of the software, well, maybe it's not so bad. Look around you. There's a lot of software and it works and people use it. And yeah, they may grumble against it, but it still mostly do the job, because otherwise they would stop using it. If we admire software, well, there's lots of software that we use daily, weekly, that we do not admire. I'm not a big fan of the software that I'm using to do that slide that you have. I actually ignore several of the menu items because I've tried them and they just run me into nightmares. Yeah, as Patrick Conroy said, it's ugly as sin. Correct, then it's mainly painful. If it's authoritarian, it's actually quite good. I mean, there's a whole software industry, and this valley is a good example of it. It's good value for creation cost. Then, okay, I don't know if we want to agree with him. The creation costs sometimes are not that bad. Good value for purchase costs, yeah, it's pretty good. So it all depends, and we had an embryo on this discussion before lunch. How do we define quality? Okay, little parenthesis about quality. You know where the first quote comes from? Yep. Okay. And if you haven't read it yet because you're below 40, well, maybe you should. There's good stuff for software people in that book. Actually, I think the guy invented OO when you look at it. There's a page or two, I read that and I say, well, this is what OO is about. Okay, even Plato had a few things about it. One of my hero, I'm actually going this fall to a big celebration, a symposium in his honor, as he's retiring in November. Hans van Vliet from Vrije Universiteit Amsterdam had this view of quality, maybe a counterpoint to what Patrick Conroy said. The sort of transcendent quality, the one that Zen and the art of motorcycle maintenance was describing, like it or not. And we don't really know what it is, but it's that quality with a capital Q. Um, User-based quality, fitness for use, product-based quality related to the attribute of software, things that we can measure on the software itself. Manufacturing-based quality, how conformant to spec it is. That's where it's very, very hard to describe in the specification, if we have specification, the kind of quality that we want. Value-based quality, when we only equate quality to value and cost, and not to bugs and level of bugs. So there's these two big aspects. User-based quality, is it fit for its intended use? That's where we have a hard time on the requirement side. We very often misunderstand whom the user really is. And there's a lot of biases. We tend to project on the user our own bias. And if we are software developers, we tend to assume that the users would want to use the same kind of tool we're using. I ran into that big time when I was the chief architect for the Canadian air traffic control system. I had these software developers who had never spent more than a few hours in an air traffic control center. They wanted to use pull-down menus and that kind of thing. When you have three gigantic screens and you're using two rollerballs and a pedal, you don't want to have pull-down menus to access certain operations. You don't want opaque windows. You want transparent windows so that the little dots can continue moving. You don't want a lot of red stuff that's flashing and blue like the one I have on this screen. There's a lot of red and green and blue. You want the thing completely subdued unless there is an emergency. So that's where, for the first time, I really saw how software people were projecting their biases onto a population of users who sort of say, we don't want that. I have a PC at home. I know how it works. But at work, I want certain things to behave in a certain way. Then there is the thing that we're suffering from, but we have to accept it, is changing needs. The needs change and they evolve as you develop the system. And actually being exposed to the system makes the need change. It's the icky-wizzy effect that Barry Beam described. I'll know it when I'll see it. Show me something, and then I will tell you what I really wanted, because now I have some baseline out of which to reason on what I wanted. So there's a lot of things that we still need to do in software engineering on being able to better articulate what are the needs of the user. I was listening to the presentation just before at lunchtime, and it struck me again as an example of dialogues for a user that assumed a certain underlying model. Why do I have to have a save button after I type all this information? Why isn't the information saved as I type it? That's still a big mystery to me, but it seems to sort of assume that the end user will behave as a software literate person, be assuming a certain underlying behavior of the system. And I see that very often with my own wife. She says, I type all the information. Why doesn't it do anything? Oh, below the screen, if you scroll, there is a submit button. Oh, okay. Why don't they put it somewhere there? And why don't they know that I'm done? And she's been using computers for a good 30 years now. So but only, twice a day, twice a week. Well, twice a day. Value-based quality. That's where a lot of the commercially organization look at software. We don't care about bugs actually. We only care about profit and cost and the balance between the two. So that's where we suffer from bad procurement processes in when software is procured as if it was trucks or garbage cans or that kind of thing. And unfortunately, a lot of administration and large companies still treat software like that. It's as if it was a commodity, although it's something that will be created especially on purpose for them. So, rewarding low bids and bad risk management and ignoring deployment cost and conversion cost, something like that, just to get the job, to get the contract, and then playing all kind of little games. Some of them ending up in courts, but sometimes just looking at how to make things work. I was surprised also when I became a prof a few years ago to notice that maybe it's just specific to that place where I am. It's not the case at Carnegie University. People do not actually know what software quality is. I was the first prof in a class of 80 to describe to them ISO 9126. They had never heard of it. Now, I know the document is $600, so you cannot expect everybody to have a copy of it. So I negotiated something with Standards Canada to get a free copy for the students, which is watermarked, unfortunately, on each page with my name on it, so that they can track who's the leaker of the expensive document. But this, there's a body of knowledge. We know these models. We know what they are. There's the whole 25,000 series, which is going to cost probably $1,000. But, it's not like we are inventing software quality in 2014. There's a long history of things, but it doesn't seem to have penetrated large swath of industry. I go around little software companies around Vancouver, they never heard of any such standard, many of them. So here, just try to highlight the quality that is visible outside of the software. That's what the user is seeing. There's the intrinsic quality inside the software, thing that we can measure on the software itself, which took a lot of attention in the 1980s. Software science and metrics started to appear. And there's, to a certain extent, the process quality. That's what ISO 9126 is. But there is a lot of value also in enumerating and defining precisely the various entities and providing some embryo of metrics for them, some way to measure them. So root cause of software quality, that was the main purpose of my survey with my friends. I was trying to understand what can we do, what hasn't been done, what should the industry do, the profession, if there is such a thing. So there are many hypotheses, and you see them. There's nothing new here for you. A lot of the low quality comes from time and budget pressure. People are pushed to develop software rapidly. Some of it can be attributed to software engineering education or lack of education in software engineering, not programming. I'm not speaking about not teaching people how to program and to debug and to use GitHub and all that kind of thing. Really software engineering, that is developing product where software is a major component, which may involve not writing a single line of code, by the way. A lot of issues in my career, I noticed, are due to a lack of domain knowledge. The software people know a lot of things about software development, but they don't know enough about the domain in which their software will be deployed and used. And when some of my own children wanted to computer science, I told them, no, why don't you study something else? You are a good programmer already. You're 16 and you know 3 programming languages. You can come back to software later, but learn some other stuff that you can apply software to. I see people that, the only thing they know when they finished, a Bachelor of Computer Science followed by a Master of Computer Science followed by a PhD in Computer Science, they're completely very deep in a certain field, but they are missing some of the stuff from out there. You're going to develop stuff that is used by a physician. A physician has not done computer science, doesn't give a damn about the programming language it's developed in, doesn't give a damn whether it's on Amazon something or cloud or whatever. He has to see things from the perspective of his own job. And it's a good idea to have people with a little bit more breadth. There's no systematic assessment of quality. Oh, we do coverage testing and this kind of testing. Testing is not just the magic wand and the answer to quality. We do not have a good culture of error and analyzing failures. Actually, we hide most of our failures, and we can, or we try to push them on other people. We tend to build systems that are overly complex. And maybe we need to educate the public a little bit better about what is software engineering, so that the public would have different expectations. We've educated the public about cars and the value of driving on the right-hand side and the left-hand side and having certain controls and commands and certain uniformity in order to avoid, catastrophe. Maybe we can do the same thing with software rather than just letting people hope that software is this kind of magic thing that's going to do everything and its opposite. Know this guy? This guy had a lot of impact on our industry. This guy is Jack Welch. He's the guy that basically pushed us, all of us, and software people in particular, into delivering things faster at a very, very fast pace. If you're not moving at the speed of the marketplace, you're already dead. You just haven't stopped breathing yet. So people like him in the mid to late 90s started to push the industry to develop product very, very fast. And when a product contains software, this has some very, very hard constraints. Before that, I would say in the 80s, if you would tell that, it would take 3 years to develop a piece of software, people would say, okay, it will take 3 years, we'll wait. Now, if you say for any size of software, you'll have to wait 3 years because, come on, can't we have a prototype or version 1 in 6 months? And then can't we make the prototype operational enough so that we can start actually using it, basically sort of going from 3 years to 6 months. Education, I already mentioned it a little bit. Computer science is too focused on itself. We focus a lot, maybe this is just a few universities that I know, on the code, the computers, the technology, and not enough on software engineering. In my own university in computer science, there is no course on software engineering, there's no course on software project management. The reason I know is that the students from computer science come to my course in electrical engineering. So one of the person I discussed with, in my survey said, computer science graduates are often expected to have an understanding of many issues surrounding the interaction between humans and computers when they are in the workplace. However, most computer science graduates are ill-equipped to deal with such issues and could benefit if they were given more consideration into the university curriculum. Now, university curriculum, they're bounded, 4 or 5 years, depending in the country where you are, with so many credits that you can take. And so we'll have to make some choices there. And usually there's part of that that can come in some further education, professional masters, the kind of thing that you're doing in this institution, that's probably good complement. But education on quality, when I start, probing that, yeah, it's hit and miss depending on the places. Now, again, this was not a very scientific survey. I didn't survey every single computer science or computer engineering department in the Western world and the rest of the world, but just, sampling. Two things are not part of the curriculum. Looking at the complete life cycle, design, coding, testing, yep, they look at design, coding, testing, but what about deployment? How do you deploy software? How do you update software? How do
train people? How do you convert? How do you interoperate? How do you maintain software? This is sort of ... on the last slide of lecture number 39, the process. And by the way, there's also maintenance, which is left as an exercise for you when you leave the university. And a good reason for that is that sometimes the educators do not have any first-hand experience with that. It's just a chapter that they read in the book on software engineering, because they just work with small project involving 4 grad students. Sometimes the project is over 2 cycles of grad students, but they're not involved in the deployment, update, training, conversion, maintenance, and interoperation. Oops, sorry, going way too fast. Where was I? Here. The application domain, I mentioned that already briefly. Software systems, yes, we build software systems, but apply to what? And that's where we need to have people that have the breadth to be able to bridge to these other disciplines, be them medical, others. Interdisciplinary teams, very often the software people are isolated. We are within software people dealing with other software people. We have used the same jargon, but then there are the other people. They're in other buildings, they use other tools, other jargon. And then there's this issue that I was trying to explain, the cognitive biases. We have a lot of anchoring bias, representativeness bias, and groupthink. So if you're interested in reading about bias, I suggest the book Thinking Fast and Slow by Kahneman, who's a prof at UBC. Can we get some help? In particular, when something in an industry doesn't work too well, we'd like to get some help. And we can get some help maybe from the governments of the countries where we live, or we can get some help from the market who's going to push, or we can get some help from the profession by making sure that the profession gets organized to sort of raise the thing to a certain level. So government, can we have quality by law? I'm not sure. We can get some help from our governments in very, very narrow domain. Now, they happen to be domain where I worked a lot, what I call software that kills. And there's 2 categories of software that kills the bad guys, but there's also software that kills the good guys. I spend a lot of time in the defense industry, having been part of this ADA adventure. So safety critical systems, yes, governments, and to a different extent in different countries, will have a little bit of a say, although indirectly. They're just going to sort of say, you have to sort of self-regulate. Can we let the market decide? When users have choices, they vote with their purchasing power. We can see some of that. It's a pretty open market. We have globalization. There may be an impact of outsourcing at some point in time. What we expect, at least, is the government to ensure that we have a free market. That is to prevent monopolies, trade barriers, and abuse of patents. And I could make a whole talk about software patents and are they good, are they bad, what's the European policy on that, and American policy on that, and that kind of thing. So there's ways where we can help there. There's also vendor initiatives. You need to have a minimum level of checks to be on the App Store. But we probably would need some more ways of having impact on the market there. What we've done in software looks like this. I was making a similar talk, and there was a lady in the background was making cartoons about what the speakers were speaking about. I was describing, we have this bridge in Vancouver. It's like your Golden Gate Bridge here. We have this bridge, it's called the Lions Gate Bridge. It goes from the city to the mountains on the other side. And if it was software, there would be a license agreement there. You say, you can cross this bridge, but it can collapse at any time. We don't guarantee anything. Press accept, and then the barrier will open, go across. So this is what would happen in civil engineering if we had the same kind of attitude. Profession. We can get organized as a profession. We can have certification. We can have, and there's many that exist of various quality. And again, we can have a whole discussion about which ones are valuable and which ones are not valuable. But that's the kind of thing we probably need to go to a further extent. We have accreditation of educational programs in major countries. So the profession will look at the programs and make sure that a certain number of basic criteria and topics are covered and some quality checks about the programs. And we have that mostly for undergrads, and there's no attempt that I know of to do that for further education. So you're out of trouble here with your master program, PhD program. Then there is this very, very controversial topic of should we have in software what we have in medicine and other disciplines, some form of licensing, saying who's authorized to do software engineering or software development. So should we have licensing? If you want to have fun, well, just Google software licensing, and you'll see that there is a lot of strange opinions and people all in favor and people not in favor and people totally outraged that we would ever do that. So this is more than certification. This is more than saying that person knows about this tool or this technique. This is actually authorizing you to do things or not. You know, it's basically a license to do work. Now, we do that in some countries like Canada for civil engineers. You cannot just build a bridge because you like building bridge and you know how to do drawing. You know, if you're not a professional licensed engineer, you just cannot build a bridge. So should we do that for software, but maybe not for all software, maybe for only certain kind of software, maybe for the software that endangers the public. But then there's a difficult definition is where's the boundary into endangering the public? Only people that think that harms people? What about the thing that harms the environment? Or things that steals a lot of money from people? It will not harm them physically, but you know, if your retirement money disappears, maybe you are harmed in some way. So that's something that's a bit of a controversy. I've been involved in that controversy because I'm the first professional software engineer license in Canada. So something that happened in the 90s. When I arrived in Canada, I worked on the Canadian air traffic control system. Actually, I worked on that system for 5 years. And somebody challenged my position as a lead software architect. Who's that guy who's not even a PN? And I said, what the heck is a PN? You call that PE in this country. And I wanted to get licensed. I thought, okay, you know, I have some significant experience, should be relatively easy. Well, I couldn't because software engineering was not even recognized as an engineering profession in Canada. So it took them 5 years to actually realize that there is a body of knowledge and we can actually assess the level of competence in people in software engineering. So if we do not have licensing, maybe we can look at ethical behavior and practice. Don't do things that are beyond your competence, and maybe just having some rule of practice, what can be done, what shouldn't be done. And there's a very good guidebook on software engineering practices developed by the British Computer Society, for example, and that we could put more into the curriculum. Actually, I distribute it to the grad students. So reading break, reading. It's called a reading break in February, so they have some readings. So we can raise the bar. I'm not sure that we need necessarily to generalize the concept of licensing professional software engineers. Maybe we need some for certain type of projects, but so there's different organizations that may be involved. Several of them are really relevant only to Canada, so I'll skip that. So back to our original question, is software bad? Is it? What can we do about it? In software in general, when we compare to other engineering disciplines, in my new role as an NSERC design engineering chair, I have to poke my nose in all engineering disciplines, not just software. And I realized that in software, we have a very low level of accountability to whomever. We just, push the risk and things to other people. We are running away from our responsibilities as software developers. We just say, okay, we'll do our best and we'll have these long disclaimers about things happening or not happening. And I see that even in contracts for bespoke software that is procured by large organizations. I've looked at a few contracts for the BC government, the government of the province of British Columbia. And it's amazing the kind of things that can be waived and things that can go wrong, to the point that, the contract is almost toothless in terms of, demanding a certain level of quality. We need more objective metrics to assess the quality of things. And okay, I'll leave this one as an exercise for Hakan, putting more metrics into assessing the quality of software. But certainly as a profession, we need to have more of a willingness to analyze and publish failure analysis. We do not publish failures. In other professions, like the medical profession, failures are published. They make a one-column paper, but it's by publishing them and doing meta-analysis over a large number of failures that we can detect some patterns and find some remedies. In the aviation domain, every error is analyzed. It's publicly analyzed, and the result spread throughout the profession by the mean of checklist or changing a design so that even the condition of the errors cannot occur again. But in software, we don't do that. We just lengthen the disclaimers in the licensing agreements and the contracts. So that's something that I'd like to see a change. Risk Savvy, that's a book that was published just a few days ago, but I knew Gerd Gigerenzer from his articles before he published this book. So we need to have a more positive error culture. Now, there is a big difference if you compare what's happening in commercial aviation and the software industry. The pilots are on the plane. If you look at the medical profession, I'm going to prescribe you all kind of treatments so you cannot sue me. But would I prescribe them to myself? No. Would I prescribe them to my wife? No. But I just do that so that I can protect myself from any claim of malpractice. But I'm not in the plane. I'm not going with you in the CT scan. Whereas the pilots, they have much more at stake. They are in the plane. They don't pilot from the ground yet, So maybe that's why we try to push things. Also, when a plane crashes, it's visible. It's very hard to hide. When you have faulty software, it's much easier to hide it. So we need to measure things, and you know probably about the first quote. It's in every textbook. The second one is interesting. The difficulty in defining quality is to translate future needs into measurable characteristics so that a product can be designed and turn out to give satisfaction at a price the user will pay. So we have this issue in software where a lot of organizations say, oh, we do our best for quality. We have this QA department that's doing all this testing, and every release is doing all this testing. Well, that's just, looking at the very narrow end of things. I think quality is not just about doing a massive amount of testing and doing more testing, and if you have still more problem, doing even more testing. Actually, it's even a misnomer to call your army of tester quality assurance. That's not quality assurance. So quality has to be injected much earlier in the software engineering process. Testing is just there as some kind of validation at the exit door. Test quality in manufacturing cars is not done by checking each car at the exit. The quality in the car is done at the design, at the process, something like that. So that software verification, yep, we've done some progress in software engineering over the years. We have, coding standards, and we have good practice, bad practice, code smells. We have some quality attributes. Unfortunately, some of them are not testable. Yeah, little progress, not dramatic. Dynamic verification, yep, test, we can do that. But we need other form of experimentation, especially when we look at fitness for use. Fitness for use is not going to be done by running regression tests automatically with some IBM rational tools. So we have these models. That's the same model that is in the ISO 25000 series on quality. The focus has been around the product itself so far. What we can measure on the software product, inside the software product, intrinsic quality and extrinsic quality. What we need to focus on is on both ends here. The quality of the process and the quality as perceived by the user community. And that we haven't done much progress yet, except in small pockets of some software. So the focus has to be more on the people and less on the code. And maybe this is related to this computer science culture where the code is the #1 top citizen and everything has to be articulated around the code. To get a PhD in my days, you had to create a new language and the compiler for it. And then rewrite the compiler in its own language. That was the mensch thing to do. Well, maybe the real issues in software engineering is more about people. The development process, how we make decision, avoiding biases, a lot of different biases. How do we communicate and collaborate? Communication and collaboration, it's pretty complex and not very well understood. We tend to tell people, oh, it's when people work together. And collaboration is when they do like pair programming or they write UML diagram together on a board. Yeah, but there's more into communication and collaboration than just two people in front of a keyboard or a whiteboard. We need to better understand quality in use, which is related to the understanding of the domain. Because quality in use, it's not about it's defect free. Yes, there may be no bug in your software and it still sucks a lot. But show me the bugs. There is no bugs. That's not the issue. The issue is the adequation to the end user. So it's not a matter of bugs. We should stop blaming always the bad quality of software on programmers. Maybe there is no bug at all. It's bug-free. There's all this cognitive aspect that we are not really prepared to. I was not prepared. I learned them on the job out of my own mistakes about what is knowledge, how people acquire knowledge, how do they understand things, how do they memorize things, what is a mental model, what are biases. Test-driven design, maybe a little bit of something going into that direction. So we need to put quality much further up in our development cycles. The level of the design, the level of validation of requirement, doing more user studies. And actually, because it's software, we can have that by having very tight loops. We can build very early prototype to validate those requirements and do user studies, providing we can change the procurement process, for example, if we're dealing with large bespoke software. Testing, yep, we won't get away from testing, but it's just one little thing we can tick at the end. The real difficulty is getting the requirements right and getting the design right and getting a design that's not just expedient to spit out very rapidly some preliminary prototype, but some design that has a lot of quality in terms of evolvability, interoperability, and all these very difficult to measure entities. The next things we need to kill is complexity. A very sweet guy, Niklaus Wirth, writes about code bloat and bloat. He's probably right. There's a lot of things that is overly complex for all kind of wrong reasons, sometimes just driven by markets. So that thing look complex. What makes something complex? When you have many things, so scale, when you have a lot of diversity of things, Okay, so you have many things, but many different kinds of things. And when there's a lot of interdependency between two things. And the kind of things, maybe whatever you want, many features, many services, many lines of code, many classes in your object-oriented design, many stakeholders looking at your system, many developers, many sites, many technology, too many managers. So whatever is the thing, you know, when you have many of them and we have a great diversity and there's a lot of interdependency, then you end up with complexity. So that's what my 1 minute on complexity. So complexity, we can take it in different ways. There's intrinsic complexity or essential complexity. We cannot make things much simpler than the concrete problem that they address. Okay. If you have something that needs to deal with 1 million customer, you can sort of say, well, I'm sorry, I don't want to see 1 million customer, I only want to see 10. And then there is extrinsic complexity or accidental complexity, which is the complexity that we, the software designers, put into the system for all kind of good and bad reasons. And we have to live with a certain amount of accidental complexity. Then, more importantly, there is the perceived complexity. Things may be simple, but they're perceived complex because there is a cultural gap or a lack of familiarity when the person looking at the software is not familiar either with the software or with the whole to which that software came into being. And this is related to maybe education. So there is a piece of software that I have to use once in a while. It's Illustrator. I find it extremely complex. Every time I have to use it, which is once every 6 months, I'm completely lost. I have to actually get back to the manual. But I have a friend and colleague, is a professional Adobe Illustrator, Adobe Photoshop, and all this Adobe product. He's there with his keyboard and he's doing something that takes me an hour to do in actually 45 seconds. So he's very familiar with it. So he doesn't see the complexity that I see. But we're speaking about the same Adobe Illustrator, the same version on the same laptop. I see, you know, I know some people, they only like, you know, command line interfaces. They hate having to pull down menus and click on boxes. And my son is like that, you know, whenever he can get, you know, at the command line level, then it's very, very fast. Doesn't have to move his hands. And another thing that plays in the perceived complexity is how deterministic the system at least looks like. If I do something with the system and it does react in a way that I can expect based on my past experience or what I see, then I will feel the system less complex, that if every time I do something, something else happens that is unexpected. And it's not, it's just because the system has a long an internal state and a long history, maybe something will happen in 2 weeks about what I've just did down. So the level of determinism, which is one of the form of interdependencies that we have here, is also going to play a role. And then how much are things visible? And then there's the, you know, there's the Apple versus Microsoft camp. You know, in Apple, you know, most of the things are hidden, so they expose relatively little, but things can be exposed gradually versus, you know, right click in Windows and you have all the options laid out for you to choose. So how much are things visible is also a delicate thing in managing perceived complexity. So complex doesn't need to be confusing. There's even a gradation. We can have things that are complicated and complex and then on the verge of chaotic. Now, going back to software, a lot of software gradually goes from relatively simple to complicated because we add a few things and we want to take care of more potential users, and then it becomes very complex. And some of my favorite software tools on the web are, you know, on this trajectory. Year after year, they add new features, and then it's becoming harder and harder to use because you have to make more choices. Now, the very good ones, they make this evolution completely transparent. You can still see just what you need and get the complexity gradually. by just exposing gradually, making visible gradually new things as you need them. Unfortunately, a lot of software has become very, very bloated. The one that, you know, my friends keep complaining to me about, the non-software people. Oh, you know, my Microsoft Word crashed while I was doing the final version of my thesis, and I cannot rebuild anything because the table of content stuff and the index stuff doesn't work anymore. Philip, you need to drive to my home and help me with it. You know, you're the software engineer. You probably know how to fix Microsoft Word. No, I don't. But that's an example of software that has become extremely bloated. Yeah, and the answer is, why didn't you use LaTeX? I love this one. Why didn't you use LaTeX? A quote from one of my compatriots and one of my favorite author. This guy is only known in North America for writing The Little Prince, but actually he wrote several other novels, and he was a pilot too. Antoine de Saint-Exupéry wrote in French, actually. Perfection is achieved not when there is nothing left to add, but when there is nothing left to take away. And I've repeated that to my software teams very often, including on very big systems like the Canadian Air Traffic Control System, where the customer wanted to have all kind of strange features to do this. And what about doing this? Maybe we don't need all this. The last point is maybe this issue about software quality, we're responsible also for it by not having a good education of the public. If the public at large understood more what software is, how it's built, how it works, maybe they would be more discriminate in their choices of software and be less sensitive to just marketing, media, thing like that. So by having a better education, some perception of low quality, which is not necessarily low quality, but some perception of low quality would be reduced, but also we would raise the bar. We don't have to use. I just said yesterday to my wife, no, you don't have to use Microsoft Access. I can show you how you can do it differently with something much simpler for what you need to do. Oh, but our IT guy said that I have to use Microsoft Access. So when people can actually say no because they're better educated and they know that they have a lot of choices and we have a lot of choices, maybe this notion of low software quality will diminish a little bit, the perception of it. It doesn't make bad software good, but it may eliminate bad software by just offering to people other choices. Now, the open source movement is helping us a little bit there by leveling a little bit the playing field. Unfortunately, the policy, especially the policies until now, this country on software patents is not helping us. Okay, so in summary, I would say, despite what the Chaos report would say, and a few, people who love to use the media to sort of cry wolf and say, "Oh, look, my God, it's so bad." Most software is good. It's good for society. To answer the first question of my body, is software bad for society? No, it's pretty good for society. And most of the software we use, most being 98%, is of good enough quality. And this is because most of the software we use, you don't see it. Now, there are the few things that we are seeing a lot. Oh, there's a bug, another bug, not an electronic one walking around. It's the real bug. Yep. So there are some we like to focalize on, and sure, we love to focalize on the quirks of Microsoft Word table of content features or whatever, or the animation feature in PowerPoint, which I stay away from now because I want to avoid catastrophe. For instance, if I had used animation, I wouldn't make this presentation today because we had to transform it into PowerPoint. Anyhow. So some software is bad, but because of the market dynamics, because of education issues, and because of some form of quasi-monopolies, which are hopefully getting to some form of resolution. The culprits are not necessarily the software developers. The reason we have bad software goes far beyond just the coders. So I'm getting tired, and I keep standing up in other circles than software engineering when I mean, in other engineering circles in Canada and say, okay, stop blaming the programmers. If software is bad, it's not because of bugs. It's because of other things surrounding the software developers, the way we've analyzed the problem, with the way we've ordered the software, the way the politics around software development and system development is also to be looked at, the way decisions are being made, purchasing decision, process decision, release, transition, and things like that. Improvement, yes, mostly by education, both the public and the developers. I've covered some of that, probably would need to cover that in more detail. A better understanding of quality based on use and value, not just based on measuring something on the code and running massive amount of tests. So quality is not more testing. Actually, if we were to build software of high quality, testing would be optional. We wouldn't bother testing it. Nobody, when you buy a car, nobody is going to test every single feature of that car when it's getting out. There's some random testing, statistical testing, but nobody is going to actually activate every single button and every single feature of that car. So we need to push some of the quality up there, upstream. So to continue on my informal survey of my friends, a few quotes to conclude. I found this one from Robert Beadle, somebody you know too. The continuing self-flagellation about poor quality is a kind of modernist indulgence that attempts to purge the sound by admission of guilt. So he says, okay, Philip, stop whining about software quality. We seem to crave purity even when it's not truthful. That's a mistake. It's Occam's razor burn. When we don't understand things, we'd better to admit it than to pretend we do. But like our medical colleagues, we can't just wait for perfect knowledge to begin applying it. Moreover, because our subject is supporting all nature of human pursuit, so the map becomes our territory. Yeah, it sounds like it. A colleague of mine who was working with me on Middlefield Road there, Joe Marasco, in his conclusion in the open comment section of my survey said, my short answer is that software is better than most people think. We take for granted a lot of very sophisticated magic that goes on beyond the scene to make it all work. As with any product or service that is used in high volume, there are occasional failures as well as things that don't work very well much of the time. In particular, we are very hard on new software. I've come to judge the quality of a software product only after it has been in the field for 20 years. Before that, it's still not mature. Systems with solid architecture that can be incrementally improved with advances in underlying technology are, from my viewpoint, the modern-day version of cathedrals. We need to judge our construction abilities on our cathedrals and not on a sampling of dog houses. Grady Booch also worked with me, but he was never on Middlefield Road. He worked from Colorado. While I may declare that software is bad, I must temper my lament by observing that I say that largely because I know we can do much better. So he's like the one that Beadle said, stop flagellation about bad software. However, when measures good or bad, I celebrate the reality that software has changed profound and irreversible ways, and that in the self-created cosmos of ones and zeros, there is a fierce and elegant beauty within the mind and matter of the software-intensive system we have created. That's also pretty much Grady. So that's some of my friends that helped me in preparing this presentation. And I hope that it was somehow enlightening and help you ask yourself some questions or ask me some questions. And this is not the result of some scientific research. This is more the accumulation of a long series of discussion with my friends, as reflected also in my own personal experience, having poked my nose into many software projects on both Bond. That's it. So the question I have is, talk about
collaboration, and communication. So once a system is designed, once at the high level, not the program, engineering level, the system is designed for some domain, for a medical office or for manufacturing, what's the best way to communicate that idea of what software functions should be to the programmers? What method have you found to be most accurate, least amount of misinformation?
First, that was not exactly the kind of collaboration communication I was describing, but I address your question. Probably one of the best ways is to expose the software developers, or at least a good number of them, to that specific environment where the software will be used. I'm going to give you an example. Canadian Air Traffic Control System. I arrived there in a project that is in total disarray. I happen to be a private pilot, and I've poked my nose into air traffic control before I arrived on this project. So what I did with the customer, I organized sessions from Friday morning till Monday night for many of the people of the software architecture team first and some of the key software developers, so that they would spend 4 days sitting next to an air traffic controller. So when I announced that, people say, "What are you out of?" And over a weekend, and okay, they can just do us a demo for 10 minutes and we'll be done. No, I said, no, that's would not get it. We don't want you to have a demo of fancy features. I want you to really experience it from the perspective of the different type of air traffic controllers over several days. So anyhow, with a little bit of arm twisting, I got that done, and I got batches of people from the team spending their 4 days in the Vancouver ATC, not far from the airport. Well, a few years later, several of them told me that was the best thing I did for the project, because they were able to look at sentences in the requirements, the massive SRSs, but they were able to put it into perspective. This sentence, which is 50 words, is far more important than this other sentence, which is 100 words. Because they were able to put it into perspective of how do people live their work with that kind of software. So it's not always feasible. Actually, it matches very well the notion of customer on site, but I would sort of say it's the developer on site, the opposite of the agile practice of customer on site. We also complemented that by having a number of, unfortunately retired, but they retired at a young age, air traffic controllers being embedded in the project. So I manage again with Transport Canada to have 6 or 7 air traffic controllers having an office inside the development team, so that any software developer could just walk to them and ask a question. So again, to bridge the gap between the two domains. Those are a bit extreme examples, but in other circumstances, you may want to take somebody from the domain and hide that person on the team and educate that person enough about software development so that they would understand what's going on. We would not ask them to actively produce code and things like that, but be the sort of domain experts. On a project, that's what I did. We had a person that came from the domain, was not a software developer, was interested in software development and had a personal computer at home, but was embedded in the team. Just putting more words doesn't work. The other aspect is creating a series of prototypes, understanding very well that those are prototypes. They should not be taken as pre-operational stuff, and we just need to do a little bit of tweaking and then you can start using it to actually get the EQEZ effect I was describing. Okay, you tell us something, you the user, or we survey the user, or we guess what the user wants. Let's build it relatively rapidly and show it to a palette of users and see how they react. But naively see how they react. I've seen people sort of inserting some bias, oh, look at what I've done and I do the demo. Let them play with it and let's observe, not saying anything. Don't even make faces when they do something wrong, because they would say, oh, did I press the wrong thing? No, let just them use it. So that's another way to accelerate the communication between the end user. There's also something that software development misses, that there may be different categories of end user, and we should not lump them into one category, the end user. I'm only one category of end user of Adobe Illustrator. My buddy is probably at the other extreme. So you need to look at it, and this is why there's a funny diagram in ISO 25010 about different category of quality in use, because the quality in use is different for the same product, depending on the various categories of users. Other ways of communicating. Okay, I'll have to think about this one a bit more. But adding more words on documents doesn't help. It creates actually more confusion, in my opinion. So a certain amount of things put down in writing and illustrated by diagrams or screenshot may help. But after that, you need to have real dialogue with the people. The idea is to have to be able to create mental models of how the system works that sort of overlaps between the real users of the system and the people who are building the system that they're going to use. Yes, sir.
The interesting thing about that is that there were multiple attempts to do the same job, and almost all of them failed. So presumably it's partly the intrinsic complexity of the problems you're describing. But I wonder if people are doing like autopsy here, because it seems like obviously valuable example to understand what makes for good software.
Yeah, it would be very interesting to do an autopsy of that. Unfortunately, they're always marketing and image and confidentiality issue. Now, probably everybody's going to sort of say, oh, you cannot do this, or it has to be secret, or which doesn't happen in aviation, civil aviation. If there is an incident, sorry, Boeing and Airbus, it's going to be all laid out in all details, including who said what and who sent an email about that and which diagrams. And so, yeah, it would be good. I don't know if there will be an autopsy of this one. It might be interesting. Yeah, but again, you'll get people shooting at the thing from the outside, not really knowing, not having been embedded in it. It would require a very careful study, but I'm not sure that any of the participants is really looking for actually getting lessons. They may be interested in putting the blame on somebody because the press would love that, and this would sort of, you know, percolate out. But actually understanding how things went wrong and correlating things, because it's not just one thing that went wrong. It's probably a combination of different things that were suboptimal that ended up in something really bad. That I'm not sure that people wanted to do that. There was another one where I was disappointed about the result. It's the AAS. I don't know if you remember that. It was the replacement for the US air traffic control system. This was running for 8 years and consumed $8 billion of your money. And it was aborted after consuming that much stuff by the FAA, which was red in the face. But there was no real deep analysis of it. A couple of people, including some from the SEI, went there, wrote something, had a few hypotheses, but I've never seen any very detailed analysis of what went wrong. And a lot of companies were involved, and each of these companies had all kind of ways to block things. You know, IBM Federal System Division was there, and some big companies that I forgot, including to some respect Rational Software, because we were providing data compilers. But yeah, that's exactly the kind of thing that I was mentioning when I say we do not have a good positive error culture. We run away from our mistakes. Company go bankrupt or product are discontinued or whatever, but we just move on and we say, oh, we'll rebuild it and we use new technology and this is not going to happen and we are agile. And so we just hope that putting some, magic potion there is going to help, but we don't actually look that much at our own mistakes. Or once in a while in a relatively narrow area, but not in a very systematic way, the way it's done in other industries or disciplines. Thank you. Okay.
Shall we stop or can we take one more question? There is one. If not, I have a final. Go ahead, Cecil. Cecil, can you push the button?
You mentioned about education topic. Do you have idea on how we can do that?
Things like that start to happen by having more computers in schools. Remember that this is not representative of the entire world. I know that there is lots of computers in the schools in Silicon Valley, but computers in the school, but not just computers that allow people to do relatively simple and static things. The computers that you can actually change, modify, program, you know, things like having Raspberry Pis and other things like that that people can play with would allow people to have a better understanding of what's happening behind the computer. Just having a nice fancy computer, giving a MacBook Air to every school children may not be the right solution. You need to understand what's below the surface so that you'll develop a better understanding of what's happening. The notion of having things in the cloud and synchronizing between multiple devices. If you have no notion of what it is, the cloud becomes this sort of magic thing. It's like in the Wizard of Oz, But if you understand how this works, yeah. If you understand how it works and you've played with it in some ways, and it's pretty, I can teach a 10-year-old how to create some instance in the cloud and run it there. It's easy. So that's the kind of education I would see, but I'm not a specialist of the thing. I just see that in other technology advances that happened over the last few years, and not trying to draw any arbitrary analogy, a lot of things happen by education of the public and a little bit help of government regulation and things like that. Maybe the same thing can happen with software too. But very often my answer when people ask me, but why does that take so long? And when I do this, it takes no time. I have to explain to them, this is done in your computer by a tiny program that is local. The other thing, it goes to the net, it goes to a server that's on another continent. It has to find out the piece of information you need out of a terabyte of stuff, and then it had to process it there, and then it goes across the Atlantic again, and then finally it's displayed. Oh, that's why it takes so much more time. Oh, now I understand. And now they're more willing to wait. But before that, they were comparing something that was happening on their laptop with something that is happening somewhere in Sweden. So that simple education like that can make people more understanding and not immediately say, oh, this is crap, it takes so long. Maybe if they understand why it takes so long, they won't consider it crap. It takes the same amount of time. That doesn't solve it. But they'll develop a better mental model of what's actually happening. So somebody recently was very excited about Siri. And then Siri was not working very fast. That person thought that Siri was inside his iPhone. He didn't realize that he had to have access to the internet. I said, well, your 3G reception is pretty bad. He says, well, what does that have to do with Siri? So that's what I mean. Sometimes it's relatively simple education if people were understanding how things work. Like I was told when I was a kid how a car works, how an engine works. It was not some magic stuff that was under the hood and you never open it.
Okay. Well, thank you. I'm going to close with the thought. What would have happened if you asked a bunch of gals the same question?
Yeah. Okay.
Just food for thought.
The girl in that list actually never replied to me.
Well, there you go.
She was too busy with her one.
Thank you for an engaging talk.